Everybody, I thought this was pretty clear, but maybe not. I am recording these and posting them again. So if somebody misses it, they can go back and watch the video to make sure you get the instruction. I also know that Miss Johnson is also doing a Google Meet at the same time. If this ever happens again, feel free to watch the other teacher's video because I know you can always come back and watch mine on the regular Google page. Okay. So don't worry about it. Miss Corbin's recording it right now, and we'll have that posted after we're finished here. Okay. Hey, make sure too that you're telling folks to go back and get credit for the work that we've already done. If you have an assignment for practice problems, you need to go in and click turn in. Don't just type done. I like that because I get an email when that happens, and I usually get that checked too. But I'm going back a couple times a week and checking to see if people have resubmitted or turned in stuff late, and I'll make sure you get credit for that. Okay. Again, any questions, any problems with the internet, anything like that, make sure that you let me know, and we'll try to work things out. Okay. Read all the instructions. Even if it's for a video, read the instructions. Of course, iExcel, some of them are going to be 90% smart scores. Some of them are going to be 80% smart scores, depending on how hard the problems get up into the 80s and the 90s. Okay, so be paying attention. Those of you that always go over the smart score, you're getting bonus for that as well. So those are just some normal things that we're doing. Okay, so let's go ahead and start with dilations this morning. I'm going to put on some notes for you here, okay? And let me know if you can't read that or if there's a problem, and I'll read them to you. But we're just going to go through them here. These are called dilations, okay? Now, dilations are different than the transformations we've been doing. These are non-rigid transformations, okay? Now, remember, rigid was like if we had that rebar, that triangle rebar of steel, and remember, we couldn't change the shape or the size. Well, dilations are non-rigid. In other words, we can change the size. Now, a couple of things about dilations. The shape does not change. We're still moving these in and the coordinate plane in different places, but the shape does not change. The size does change. So if you start off with a big triangle, you may end up with a small triangle. If you start with a big quadrilateral, you may start off or finish with a small quadrilateral. So the pre-image is either going to enlarge or it's going to reduce. Question, I would definitely take these down in my notes. Again, you can always come back to the video if you want to, but these are just some simple things. If you can understand these simple things, I would go ahead and write these down as notes to have. But again, you feel free to come back and look at the video later if there's any questions, okay? So again, in dilations, these are non-rigid. The shape stays the same, but the size goes from bigger to smaller or from smaller to bigger, okay? And we call these enlargements. Of course, an enlargement is where something gets bigger, and a reduction is where something gets smaller. And here's the way you need to think about it. Everybody pretty much has either gotten on their phone and taken a picture and cropped it, okay? You can either put two fingers on it and you can do this and it gets bigger, or you can put two fingers on it and you can go like this and it makes it smaller. That's exactly what a dilation is. A dilation is taking those vertices and stretching them, or taking those vertices and reducing them, okay? And we stretch them or we reduce them by a thing called a scale factor, okay? Now, a scale factor is just a multiplier to the coordinates, okay? So you think about it, the vertices of a shape have coordinates to them, right? They have an x coordinate, they have a y coordinate. We put them in parentheses, and it might be 2, 3, it might be -4, 2, whatever the case may be. Those are the vertices of whatever shape we have in the coordinate plane. A scale factor is a multiplier to the coordinates. And so here's what it's going to do. We take the scale factor, whatever it is, and we multiply it by the x coordinate and the y coordinate in each vertice. And when you do that, it's either going to enlarge the vertice or it's going to reduce the vertice. And when you do that to each vertice, what happens is the picture becomes bigger or smaller. Again, just like you have on your phone, if you took your two fingers on it or your thumbs and you pulled it like this, it's going to get larger. If you put your two fingers right here or thumbs and you did this, it's going to get smaller. That's what we're doing with these dilations, okay? Hopefully you saw that in the video, pretty good video that I sent, I think. It wasn't too long, but it did give you an idea of what these dilations are. Now, just a couple of hints here. If the multiplier, or what we call the scale factor, is between 0 and 1, and there won't be any negative scale factors, they'll always be between 0 and 1 or greater than 1. Now, between 0 and 1 means it's going to be a fraction, right? Might be 1/2, it might be 1/3, whatever it is, it's going to be a multiplier. If it's a fraction, it's going to reduce the picture. It's going to make it smaller. And you think about it, if you multiply any number by a fraction, it's going to get smaller, okay? And that's what's going to happen to each of your vertices. If the scale factor is greater than 1, you're going to have an enlargement, okay? So again, if it's greater than 1, it's going to be an enlargement. Between 0 and 1, or a fraction, it's going to be a reduction. And all of this comes from this scale factor, which is a multiplier to the coordinates, or the vertices, okay? All right, so let's look at one of these, and let's see what we can do here. Okay, so go ahead and write down my picture. Draw your coordinate plane. And we've got just a triangle here. Hopefully I made it big enough, and I wrote down the vertices so you can see those. But just take you a minute to write those down. Some people were talking to earlier in the week about getting kicked off of these, not being able to stay on. A lot of times you get kicked off of your Wi-Fi because you have too many different devices. I know that's what happens at our house. You know, we've got 5 of us, and if somebody's streaming, or even 2 of my girls are on doing something as a student, a lot of times the Wi-Fi can't handle that, and it'll boot you off, or it'll freeze. So when you do these Google Meets and things, you may want to make sure your other devices are off the internet. I know that's what we try to do here at the house. And again, if you have any problems with anything like that, make sure you contact me and tell me, okay? Now, this is a time where we need to try to work together, and I'm going to try to help you. And I certainly don't want to cheat anybody anything that they deserve, okay? Just try to do the simple things like watching the videos, working the practice problems, and getting those turned in. And if there's an issue, make sure you tell me, okay? All right, so scale factor of 1/2 is what we're going to add, or what we're going to multiply to each of these vertices. So ask yourself, from what you know already, if a scale factor is between 0 and 1, what's going to happen to this triangle? Is it going to be an enlargement, or is it going to be a reduction? Well, I think if you look just at your notes, you'll understand anything multiplied times a fraction is going to shrink the number. It's going to make it smaller. Yeah, that's right, Wesley and John. It's going to be a reduction. So, I mean, it's really just that simple. You're going to take each vertice and you're going to shrink it by 1/2, okay? So I'm going to take H here, and H is -4, 6. And so H prime, okay, if I take half of, and taking half of, it means the same thing as multiplying, or dividing by 2, if you want to do it like that, is going to give me -2, 3. Okay, and I'm going to do all of these. J was 4, 2. And so you take half of 4 and half of 2, and J prime gives you 2 and 1. And all I'm doing is I'm multiplying 4 by 1/2 and 2 by 1/2, and that's the same as dividing by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. And then let's do K. K is 4, -6. And so K prime is going to be half of 4 is 2. Half of -6 is -3. Okay? Does everybody see what I did there? All I did was I take my scale factor and I multiply it times each vertice coordinate. And again, multiplying by 1/2 is the same as dividing by 2. And so now we draw our new shape. So H prime is -2, 3. So we start the origin, -2, 3. Okay, that's H prime. And then 2, 1. That is J prime. and then 2, -3. Okay. Did I mess up somewhere?
You messed up H.
I messed up H, my wife says. -2, 3. How did I mess up H? Oh, I see. It's -4, -6. So that's going to be -3. Sorry about that. So -2, -3. I just copied it down on. Okay, so that's H prime, and that's K prime. Okay, yeah, be careful with your negatives because they're not going to change. All right, so let me redraw the figure, and then I think I may have a question. Oh, look at that. That's bad right there, isn't it? Needed to have brought a straight edge home. Okay, question? Yeah, if you know Miss Corbin, you know she's not a math person. She's a language arts person. So when she knows something's wrong, then that's not good. Okay, how do we get the primes, Michaela? Again, you take the vertices, the original vertices, okay? Make sure you write them down, right? I had missed a negative. And then all you're going to do with the original vertices is multiply each coordinate by the scale factor. So half of -4 is -2. Half of -6 is -3. That's because my hand was in the way. Okay, any more questions? Johnny, you laughing at me or Miss Corbin? Hey, I really do miss you guys, by the way. I hope I make that clear. I really miss us being together. So I know it's nice getting some time off, but I want to make sure you guys are ready when you hit Algebra 1 next year because that's coming either way. Okay? Yeah, Lily, all you're doing is just multiplying by 1/2. You multiply each one of the vertices. And again, not just, you do each coordinate, okay? Like right here, I multiplied 4 by 1/2. I multiplied by 2 by 1/2, okay? And so that's how you get the prime. And again, the pre-image is, remember, is the one we start with. The image is the prime after we've dilated it, okay? Let's do another one.
Got a question.
All right, let me see. Question. What is get, Kyler? I tell my dog all the time, I say, get out here. Yeah, that's all you're doing. Again, enlargement, if the scale factor is greater than 1, it's going to get bigger. If the scale factor is a fraction or between 0 and 1, it's going to get smaller. That's a reduction. Okay? All right, so go ahead and write this one down. I've got the vertices written on there for you. Hopefully you can see that. And what we're going to do is we're going to dilate the pre-image with a scale factor of 2. Okay? Now, you already all should be knowing if it's greater than 1, is this going to be an enlargement or a reduction?
That was me.
Remember, scale factor greater than 1, definitely going to be an enlargement because you're just multiplying each coordinate by, yes, you're right, Kaya. It's going to be an enlargement because it's going to get bigger. It's going to stretch the shape. Again, think about this like you're cropping a picture on your phone or on a laptop or iPad or something. You put your 2 fingers down and pull it, stretch it. That's an enlargement. You put your 2 fingers on it and you push them together. That's a reduction. That's all we're doing right here. And you just do that by multiplying the scale factor times the vertices. Okay? So let's do this one together. Maybe I won't mess this one up. It's bad when a language arts teacher's got to correct you. So that embarrasses me. So I'm going to try not to do it again. All right. So scale factor of 2. So I'm going to start with A. And I would write these down just like this. Again, it makes it easier to catch mistakes like a while ago. It was easy for me to go back. So now I know A prime is going to be multiplying each of these by 2. So I'm going to multiply that by 2. I'm going to multiply that by 2. And so my new A prime coordinate is going to be 4, 8. Okay, and then I take B, and it's 5, 4. So I know B prime is going to be, well, multiply each one by 2. That's going to be 10, 8. Okay. And then C is 2, 8. And so if I multiply each of those by 2, I know my C prime is going to be 4 and 16. Okay. And so let's see if I've got enough room to put that on here. Okay. So A was 2, 4. So now I'm stretching it to 4, 8. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So that now is my A prime. B was 5, 4. So I'm going to go to 10. B prime is 10, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8. That's my B prime. And then C goes to 4, 16. So 1, 2, 3, 4. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Just enough room, right? So that's my C prime. All right. And so now I recreate my shape. Golly, that was bad right there, wasn't it, Collar? All right. And there you go. Again, even without a straight edge, you can see that the shape is an enlargement, right? Now, again, the center of dilation for these is the origin. I didn't tell you guys that earlier. Sometimes they make the center of dilation one of these points, and you end up just multiplying and lengthening the sides by that much, okay? But most of these are going to be with the center of dilation at the origin. And so, again, all you're doing, I took each coordinate, and I multiplied by the scale factor, whatever it is. Now, the clue to you is if it's greater than 1, it's going to get bigger. If it's smaller than 1, if it's a fraction, it's going to be a reduction. It's going to get smaller, okay? All right, questions on that one? It looks blurry. I don't know why. All right, everybody okay to move to the next one? Yeah, John, I thought mine was going to go off the paper too. Look, I had one little square left. All right, let's try one more and then we'll be done for the day, okay? All right, let's try this one. This is a big quadrilateral. And we're going to do a scale factor of 1/3. So go ahead and make your coordinate plane. If you need help, I've got the coordinates written on there, but if you can't see them, it gets blurry or something, let me know. What do you think it's going to be? Is it going to be an enlargement or a reduction with a scale factor of 1/3? Definitely a reduction. Yeah, you guys are right. Yeah, that's funny, Callie. I'm recording the session actually on my phone, and it's just as clear as it can be. And I could squeeze it down really close, just like you would zoom in on a picture you're taking. But it's not doing that on my wife's computer. It just gets blurry and where you guys can't see it at all.
I think that's the connection.
It may be the connection. We're going to play around. I've got my document camera, Elmo, and we're going to play around with that over the weekend and see if that's any clearer. And maybe next week I can use the document camera and it'll be a little clearer for you guys. If you haven't noticed what we're trying to do, I'm trying to get you guys in a routine. We do an introduction video that you watch a day before the Google Meet. I introduce the lesson to you on Google Meet. I give you some practice problems after the Google Meet. And then the practice problems you do take a picture of, turn in, click turn in, actually on Google Classroom. And then I actually do a video working the problems so you can go back and see what you did wrong, what you did right. And then we're trying to do some type of assessment after that, okay? So we'll probably do this. And, I've been stretching it out where one week maybe you'll catch it all. And if not, we'll go into the next week. So we may even, like we took Wednesday off of this week. I kind of pushed didn't give you an assignment for Wednesday. We'll probably try to do that from now on, okay? And the assessment has been IXL, and you guys know I'm not a huge fan of IXL, but it's kind of what we've got right now, and it's been pretty good trying to test you guys on what we need to test on. I really like it that there's a tutorial there that you guys can look at. I know this whole thing kind of depends on me trusting you guys, so I hope y'all are doing a good job with that. And again, if you have any problems, send me a message and we'll see if we can't work it out, okay? All right, so this quadrilateral, we're actually going to reduce. It's a reduction of 1/3. Now, I know some of you, you see that fraction, you go, oh my gosh, I've got to multiply by fractions. Multiplying by 1/3 is the same as dividing by 3. And if you look at the vertices, what you're going to notice is each vertice are all multiples of 3, right? So they actually most of the time make this really easy on us. You probably don't even need a calculator, okay? So let's start up here, and we're going to start with W. And we're doing W is -6, 3. And so I know then W prime, I'm going to divide each of those by 3. So it's going to give me -2 and 1. X starts off as 6, 3. And then X prime is going to be 2 and 1. Okay. Y coordinate is 9, -6. So Y prime is going to be 3, -2. See how that works out? I mean, it's really nice that the coordinates are all multiples of 3, because multiplying by 1/3 is the same as dividing by 3. So don't stress over that, okay? And then Z is -9, -6. And so that means Z prime is going to be -3, -2. Okay, kind of squeeze that in there. You guys see that's -3, -2. Okay, now let's take our primes and graph them. So -2, 1. Okay, that's W prime. X prime is 2, 1. Y prime is 3, -2. And Z prime is -3. Wait a minute, what am I doing? I'm not even on the origin. How come you guys didn't tell me that? Yeah, I know. Let's try it again. All right, -2, 1. That's W prime. And then 1, 2, 1. That is X prime. And then 1, 2, 3, -1, 2 is Y prime. And then Z prime, -1, 2, 3, 1, 2, right there. And just redraw it. I was thinking that was the origin. You guys can laugh at me. All right. W prime, X prime, Y prime, Z prime. And again, scale factor of 1/3. I just multiplied each vertice by the 1/3, or again, dividing by -3. Okay. All right, guys. I'll have some practice problems for you probably posted later on tonight. And you guys will have all tonight and then tomorrow to get those done. Okay. You guys, anybody that has any questions can stay on. Just make sure that if you have some, go ahead and chat with me on that, and I'll stay on here as long as you need, okay? Hey, I love you guys. God bless you. Okay, anybody have any questions? Are you guys piggybacking on my Google Meet so you can see and talk to each other? I don't know if I need to give you extra credit for that, Sue. What do you think I need to do, Miss Corbin? Stay on here and listen to their conversation?
Mm-hmm.
Ooh, Miss Corbin says she's ready to hear what you guys have to say. Yeah, I don't care, baby girl.
Yeah, tell them we heard them.
Yeah, we heard you. Yeah, and we actually even seen Haley. She had the blanket over her head.
Yes, okay.
Okay, is P8 the rotation or the reflection, Diane? Let me see. I can tell real quick here, Diane. Yeah, P8's the reflection. Let me see, Diane. I think we can come up with one here real quick. Let me draw one. And then, Diane, you and I can work it if anybody else has the problem. Okay, Diane, here's a triangle. And if you, again, these are reflections. And remember, a reflection is called a flip. So a lot of times we're going to flip over the x-axis, which this is x and this is y, or we're going to flip over the y-axis. The only other one that they may ask you to flip over is a 45-degree line. And all you do is you take the coordinate, each vertice, and you count how far away it is from the line of reflection, and then you count away from the line of reflection that many. Okay? So Diane, you with me? Kaya, did you dye your hair, or are you having trouble with reflections? And I'm assuming you're going to have trouble with reflections. Okay, so all you do, get your coordinate plane drawn, and draw this little triangle. This right here is 1, 1. This right here is 1, 2, 3, 1, and this right here is 3, 1, 2, 3. Okay, and so all I'm going to do is I'm going to count. If I'm going to, let's say that I'm going to reflect over the x-axis. Okay, here's the line of reflection, and I'm going to count. A is 1 away, so that means A prime is going to be 1 away on the other side. Okay, B is 1 away from the line of reflection, so I go to the line of reflection, and I go the opposite direction, and that's B prime. C is 1, 2, 3 away, so I come to the line of reflection, and I go 3 away on the other side. 1, 2, 3, and that's C prime. And that's your reflection. See how it flips over the line of reflection? And again, the size doesn't change and the shape doesn't change. This is a rigid transformation. It just flips over the line of reflection. If you wanted to take your paper and tear it out of your binder and just fold it on the line of reflection, those two shapes should be right on top of each other. Does that help? What about you, Kyle? I can do another one if you guys need to see another one, or if you want me to change the line. You guys just let me know what I can do to help you, okay? Kai, you want me to work another one? Or we can reflect this one over the y-axis if you want to do that. Okay, let's reflect it over the y-axis. Okay, so that's over the x. So now we're going to reflect over the y-axis. Okay, so again, you find your line of reflection, and you're going to take each vertice and you're going to count to the line of reflection. So A is 1 away, so I'm going to go on the other side. And so A, and I'm going to call it double prime, okay, is 1 away. B is 1, 2, 3 away. So again, we're going to go to the other side, 1, 2, 3 away over here. And that's B double prime. C is 1, 2, 3 away. So C double prime is going to be 1, 2, 3 away over here. So that's C double prime. And you see now you flipped it. You flipped it over the y-axis. Okay. How about that, Kai? Is that better? Okay. Well, you guys can go back and look at the practice, look at the videos. Remember, the first video that I sent you guys had all 3 of the rigid transformations in it. Okay. Had the rotation, had the reflection, and also had the translation. So you can go back and look at that. And if you have any other problems, go ahead and ask me on Google Classroom, or you can send me an email. Okay. All right. I'm going to sign off, guys, if there's nothing else. All right. Love you all.